Hey guys, picking up on slide 25 of the chapter 4 PowerPoint. So I've got my mole map that I've fully expanded out to show a lot more information than we had before. We can deal with solids, liquids, gases, and solutions now. So given the problem that's on slide 23, it describes a chemical reaction. It says that we are mixing barium hydroxide with sulfuric acid to form barium sulfate. So when I start writing barium hydroxide plus sulfuric acid, I realize that's a double displacement reaction. They told me that one of my products is barium sulfate. If I'm looking at what's going on, I also have hydrogens and hydroxide, so I also need to make water. Balance the equation, it's 1 to 1 to 1 to 2. So there is my reaction that's going on. Now, the problem asked me to find the mass of the barium sulfate, which is my precipitate that forms. They want to know how much forms if I react 30 milliliters of 0.15 molar barium hydroxide. So, on my mole map, my starting point, I know the molarity of the barium hydroxide, and I know the volume. Well, of those two, the volume is a starting point. Okay, so I need to start with the volume of the barium hydroxide, and I'm going to multiply by the molarity to get to the moles. Okay, we're going to do it with dimensional analysis, so it's important to show all your units and that kind of thing. So it does tell me it's 30 milliliters, so I'm going to go ahead and convert that into liters. It's going to be 0.03 liters of barium hydroxide solution. So that's my volume of A. If I'm going from volume of A, it's 1 step, 2 steps, 3 steps to get to the grams of a solid, which is what I'm going for. So I know it's going to be 3 steps. And if we follow the map, it's a pattern that we're following, okay? And when we follow a pattern, that means it's predictable. We're using the same type of calculations every time. So a good chemistry student is going to follow the pattern instead of trying to create a new way to solve a problem every time. It's not new every time, it's the same stuff over and over. So my 3 conversions. To move from volume of A to moles of A, the molarity is my conversion. The molarity of the solution was 0.150 molar. That means 0.150 moles per liter. That's my conversion unit. So I'm going to say 0.150 moles to 1 liter. Liters cancel, so now if I multiply those numbers, I'll have the moles of A. Then I need the ratio of A to B. Well, that's barium hydroxide to barium sulfate. Those are the 2 things that are mentioned in the problem. So 1 barium hydroxide makes 1 barium sulfate in my balance equation. So 1 BaOH2 to 1 BaSO4. That gets rid of barium hydroxide. So now I have moles of barium sulfate. Now I'm here on my map. My last step, I want to go to grams of barium sulfate. So I have to add up the molecular weight. I'm pretty sure the molecular weight of that is 233. There may be a decimal or something, but I'm not worried about it. So 1 mole is 233 grams of barium sulfate. So now I'm going to punch it in my calculator. It's going to be 0.03 times 0.15 times 233. I got 1.05. It's actually 1.0485, but if I look in the problem, the 2 numbers that are given are both 3 sig figs, so I'm going to call it 1.05 grams. That's the amount of barium sulfate that should be formed in this reaction given the numbers we had. Now, again, if that's how much should be formed, that is a theoretical yield that we just calculated. All right, so if I go to the next slide, slide 24 describes another reaction. It's a very similar setup to this one, and I actually gave the answer to that problem. It's 0.8 grams on the slide. So rather than work another problem just like this, I'm going to leave that to you guys. The answer is provided. Hopefully you can work your way through it. Ask questions if you need to. Okay, so we're going to go to slide 25. All right, so slide 25. Describes a reaction, says we have two solutions that we can mix together, and it's lead 2 nitrate, so PbNO3 twice, plus KCl. They're both solutions, so I'll put aqueous by both. Yields. Now again, this is a double displacement reaction, so I'm going to make lead chloride, Pb with Cl. The lead is +2, the chloride is -1, so it's PbCl2, plus K with NO3. They're both +1 and -1, so that's going to be just KNO3. Okay, physical states. Chlorides are usually soluble, but not silver, mercury, or lead. This is lead, so that's going to be a solid. KNO3, potassium's a group 1 metal. Group 1 metals are always soluble, so this is aqueous. And then finally, balance the equation. I see 2 nitrates over there, so I'm going to put a 2 here. That gives me 2 potassiums, so I need a 2 here. So there's my balance equation, 1, 2, 1, 2. All right, so I have the setup now. Question asks how many milliliters of each solution must be mixed to produce 2 grams of the precipitate. So I'm looking for 2 different answers here, which means I'm going to have to work two problems. All right, so 2 grams of the precipitate. Lead chloride is my solid that I'm making. That's my precipitate. So I'm going to start with 2 grams of PbCl2, and I want to know the milliliters of one of my reactants. So I'll do the lead nitrate first. Milliliters of PbNO3 twice. Okay, now to go from lead chloride to lead nitrate, that's from grams of A to the volume of B. That's going to be 3 steps. But when I go from the grams of A to the volume of B, it's going to be in liters, and the answer needs to be in milliliters. So I'm going to have to do one more conversion at the end just to change milliliters to liters. So again, that one's not on my mole map, but I know that I'm going to have to do that to get my final answer. All right, so let's just kind of work our way through. So I'm starting with the grams of lead chloride right here. So I have to get the molecular weight of lead chloride, which lead is 207.2, chlorine's 35.5, so 71 plus 207.2. It's going to be, I think, 288. So it's going to be 288.2 grams to 1 mole. Again, double check that. If I got that molecular weight wrong, it might be off a little bit, but I want to keep moving. Then my ratio and my reaction, lead chloride to lead nitrate, 1 to 1. So 1 PbCl2 to 1 PbNO3 twice. Okay, and then that, so the first step took me from grams to moles. The second step took me from moles of lead chloride to moles of lead nitrate. Now finally I want to go to the volume. Again, if I over here it was molarity, so over here it's also a molarity. The molarity of the solution for lead nitrate is 0.25 molar. Now right now I have moles on top, so I'm going to flip the molarity this time, put 0.25 moles to 1 liter. That's my molarity, but flipped over because I need the moles to cancel. So now I have my answer in liters. The answer has to be in milliliters, so I need to do one more step, 1 liter to 1,000 milliliters. All right. When I do that, so 2 divided by 288.2, also divided by 0.25 times 1,000. So I got the answer is 27.8 milliliters. So, in order to produce 2 grams of the product, this is how much of the first reactant I'll need. Now, the question wants to know how much of both reactants. So essentially, I need to do this whole process again, starting with 2 grams. Again, this is how much I want to make. but now I need to know how much of the other reactant I need, which would be the milliliters of KCl. So this problem is kind of like if you're baking for, you're baking for a bake sale and you want to make 50 cakes and you think, okay, well, I need to go to the store and buy flour and sugar and eggs. Well, you have to figure out how much of the ingredients you need to make the product that you want. If I need 50 cakes, I'm gonna have to go buy a lot of flour, a lot of sugar, and a lot of eggs and whatever else. I have to get enough of all those to mix them together to make the product. Same idea, the reactants are my ingredients. My reactants are my ingredients, and I need to know how much of them to get to make my desired amount of the product. They told me I want to make 2 grams of the product. So I'm just trying to get the reactants I need to make that happen. Okay? So again, the first step I did all the way across. The next one is going to be very similar. The difference is this time, the first step I'll go from grams to moles the same way. The next step, it'll be a different ratio because it's the ratio of KCl to lead chloride. So it's going to be a 2-to-1 ratio. And then the next step will be the molarity, this time the KCl molarity, which will be 0.1 molar right here, but it'll be upside down. The 0.1 will be in the bottom and the 1 liter will be in the top. And then again, you have to change it to milliliters. Okay, so if you work through that, you should be able to get this number. And then if I mix these 2 numbers together, that will give me the product that I want, theoretically. All right, now the next slide actually says, okay, given all this information, we have mixed together the exact right amounts of the lead nitrate and the KCl. Once we figure what these numbers out, we've mixed together the exact right amount of both compounds to make the product that I want. Okay? In that case, both reactants are going to get used up. If both reactants get used up, that means that the ions that were used to make the product, which remember, the lead chloride is my real product. So all the lead and all the chloride are going to get used up because I mixed together the perfect amount. So basically the lead and chloride, there should be none left in solution. Both of them get fully used up, converted into the product, they're gone. But the other ions, the nitrate and the potassium, are called spectators. If we wrote out the net ionic equation, what we would find is that KNO3 doesn't really form in that solution. The potassium ions and nitrate ions are both floating around separately, and the slide number 26 is asking us to figure out how much of those ions are still floating around the solution. To figure that out, all you have to do is take the volume, multiply by the molarity of that solution to get the moles, and then if I know the moles of this compound, the nitrate will be twice that much. So that would multiply by 2 to get the moles of nitrate. And then I'll divide it by my total volume. The total volume will be the sum of these 2 numbers. Okay? That'll give me the concentration of nitrate. Now, I'd like to work all that out for you, but honestly, that would probably take another 10 minutes of the video, and I don't think I have time for that. So I'm going to leave that to you. In the next video, I'm just going to move on past that. It is not an easy problem to do, but I talked you through the steps of it. You're going to do the same kind of thing for the chloride to get the for the potassium to get its concentration as you did for the nitrate. So give that a try. Feel free to talk about it on the discussion board. If I need to, I can put it down on paper, take a picture of it, and upload it. Okay? So we're going to keep moving to the next topic.